So this is just going to be a super brief overview of rational functions. A rational function, let's say r of x, has the form p of x over q of x, where p and q are polynomials. The domain is all real numbers except where q of x is equal to 0. And that's because we can't divide by 0. We will go into much more detail about graphing rational functions, about end behavior and vertical and horizontal asymptotes as the semester progresses. For now, it suffices to say that you can use a graphing utility to get an idea of what they look like and what their major features are. So the important thing right now, though, is that you know how to find the domain. So you'd set the denominator equal to 0 and exclude all those values. The other thing is you want to be able to find the zeros. So let's do an example. So example, and we're just going to keep it simple for now. Let's say our rational function is equal to x plus 1 over x minus 1 times x plus 2. The first thing we'll look at is the domain. So if you hear some strange noises behind me, it's because I am working from home today, and I have a 4-month-old kitten who is actually in here with me, closing doors, playing with pens, and generally just being kitten-like. So excuse excuse the strange noises. I'm not making these videos in my office. So the domain. Again, we're just going to look at whatever makes the denominator 0. So we have x minus 1 times x plus 2 equals 0. Means that x minus 1 is 0 or x plus 2 is 0. So x is equal to 1 or x is equal to negative 2. Therefore, the domain, if we write it in interval notation, you can think of it being all real numbers. Here's negative 2, negative 1, 0, 1, 2, except there's a hole right here, and there's a hole right here. And so it's all real numbers in between. An interval notation, we'd have from minus infinity to negative 2, union from negative 2 to 1, union from 1 to infinity. Now, the other thing we want to look at for a rational function are the zeros. So zeros. In a rational function, the zeros occur whenever the numerator is equal to 0. So wherever p of x equals 0. So we have x plus 1 equals 0, which means x equals negative 1 is a 0 of this function. If we were to go to graph our function now, we would know a couple of things about the way that graph looks. So first of all, wherever the denominator is 0, so the things that aren't in the domain, again, here and here, we would have vertical asymptotes at those points. So let's see. Let's put a scale on our graph. And so we'll have vertical asymptotes at -2, which means there's like a dotted line right here. X can never be -2. We'd also have a vertical asymptote at x equals +1. The other piece of information we have is a 0 of the function. We know that at x equals -1, the graph passes through that point. Now, of course, we can use other information to graph. We could plot some points. We can find some other information to figure out what this graph looks like. But those are the essential pieces of information we have right now. Again, the domain also tells us about vertical asymptotes. So there are vertical asymptotes at x equals -2 and x equals 1. So precisely those values which we excluded from the domain. And so that completes our very short, brief introduction to rational functions.